anything, or you want to keep it as is, or you want to move anything to the other side? You want to move this one? Is it okay? Is this cube? Is this okay? The same thing, right? Okay, so you want a cube? Correct? Okay, let me just tell you what a plus b cubed is. A to the third plus 3a squared b plus 3ab squared plus b cubed. So when you cube a binomial, this is what you get. So the first term is this. When I cube it, I get x squared plus 3 times the first term squared, which will be this, times the second term, which will be 6, plus 3 times this, which is the cube root of x squared, times 6 squared, which is 36, plus this to the third power, equals 125 times the cube root of x cubed, which is x. Do you want to work with that? Is it clear? That's what I was saying. When we square a binomial, we get 3 terms. But when we cube a binomial, we get 4. With these coefficients, 1, 3, 3, 1. And this is horrible. You can't get rid of this. You can't proceed in any way, shape, or form. And imagine if we had kept 3 terms on this side. We would have had 9 terms. It's absolutely impossible. So this does not work. The only hope we have is that it's quadratic in form and we can use the substitution.
So when you did the graphing calculator earlier, you mentioned...
You could possibly use the graphing calculator to get this. And
no, previously you mentioned like 2 were imaginary and 1 was...
That was a cubic polynomial.
But how would you say you didn't have a method to solve an equation and you had to use the graphing calculator? How would you want us to write out the solution we got on the calculator? Because they were all like decimals.
Correct. Normally the problem will ask you to use such and such number of decimal digits.
Okay.
So if it says 3, use 3 and round off the third one. If it says 2, then we round off the second.
And if it didn't say anything, we would have just need the exact.
It's your decision. It means that I'm having 2 decimals, at least 2.
Okay.
Yeah. Very good question. Anything else? Anything else? Okay, I think we have completed 2.6. So let's see what I have next. I have time for this. This document you do have. So there are a lot of expressions in calculus that need to be simplified by factoring. So we're going to look at 2 examples of
Which supplement is that?
this is a supplement called Simplifying by Factoring. Simplifying by Factoring. You do have this one, I know for sure. Of course, please read the first pages. If the method that I present in class is not super clear to you, or if simply you want to compare to other methods, please read this. If not, just pay attention. Everyone will be fine. As long as you do what I kindly ask you to do every day, you will become experts, and I'll invite you to teach this class next semester, and I will sit down and relax. Okay, so we are looking at simplifying by factoring supplement. Sometimes I try to write fast and I shouldn't. Simplifying by factoring. And you should say factoring again. Yes, because this is something different. I would like to look at an example that I'm going to make up first, and then we're going to look at, I'll ask you to choose examples from here, whatever you want. Okay, so let's say I have x to the 4th minus 3x squared plus 4x. And I will ask you to find the greatest common factor, and I will pull it out. What will you say? Of course. And you will say x. And now please pay attention to my explanation, because I'm going to use the same idea in a minute. From power 4, I subtract power 1, and what I have left is x to the, very good, awesome, minus 3. From power 2, I subtract power 1, and I get x, plus 4. From power 1, I subtract power 1, and I get power 0, which means 1. Any number raised to 0 is 1, but not 0. 0 raised to 0, you have to wait till calculus, is not 1. This is an indeterminate case. Okay, so we agree with this? Is the concept clear? Now let's say I want to check. X times x to the third, copy the base, add the exponents. X times negative 3x, copy negative 3, copy the base, add the exponents. X times 4, 4x. Is this clear to all? Awesome. Please choose. Let's start slow and then go to further more. So you have all the answers in the back, whatever they are, and please choose the problem you like. Let's say we choose one from the top and one from the bottom. You want to start with 5. Excellent example. So 5 from the supplement. 2, x minus 4, 2x plus 7 cubed minus x minus 4 squared times 3, 2x plus 7 squared times 2. Pay attention to my copying. You already know. Sometimes I copy something else. I normally designate one student to watch my copy. Okay, assuming I copied it correctly, my first question to you is how many terms we see at the top? Say it again? I couldn't hear. I heard 5. How many? 4. I heard 5 and I had 4. Heard 4. Okay. How many? Of course. This is a term, and this is another term. There are exactly 2 terms at the top. By terms we mean quantities that are added and subtracted. Indeed, 2 terms. Our next step is to clean up the second term. I don't like it the way it is presented. I like the first term, and now I like the second term in a correct order with the numbers in front. My next question to you is, what is common in both terms? We identified 2 terms. We know that, and we see that something is common. Easy, slowly. I see a 2 in front and I see a 6 in front. What is common? 2. I see an x minus 4 and I see an x minus 4 to the second power. X minus 4 to which power? Perfect. I see 2x plus 7 to the third and I see 2x plus 7 to the second. To the? Excellent. Let's stop for a moment. Please let me know whether this is clear or not. Yes, Ben, go ahead.
So when you took the 2 and the 6, and you got 2.
2 and 6 have 2 in common.
Oh,
Yeah.
You see 2 in TCF.
Yes, exactly. Exactly. The greatest common factor. Very good. Awesome. Now let's look at this first term and say the following. Please watch. 2 is out. X minus 4 is out. From power 3, I subtract power 2. What do I have left? Indeed, exactly what we just did. I reached the minus sign. Copy it, please. From 6, I took a 2 out. What is left? Very good. From x minus 4 to the second power, I took out an x minus 4. X minus 4 is left. 2x plus 7 squared, 2x plus 7 squared. Done? Now we have to perform the operations we have in brackets. And also, let me know if this is a legitimate operation.
Yes.
Of course, because we simplified what? Factors. We simplify factors. Yes, please. Okay, perfect. So, 2 quantity x minus 4. We'll see in a minute what is left there. And then 2x plus 7 to the 4th power. I have a 2x plus 7 minus 3x plus 12. And now we combine like terms. Blah, blah, blah. So 2x minus 4 negative x plus 19 divided by 2x plus 7 to the 4th. I prefer taking out the negative sign from here, putting it in front, and you'll see why, especially when you get to the next level in math. Not too bad, right? Would you agree?
You
Yes?
take a negative out
Of x minus 19, yes. So negative 1 comes from here. And if I factor out from negative x, I have to factor from 19. So I pull out negative 1, and I got x minus 19 and minus in front. I'm sorry? Other questions? Yes, please.
So how can you cross out the 2x plus 7 that's in the brackets with the denominator and not factors because it's in brackets?
This one is not a factor.
No, but when it was in the bracket, what was it?
No, this one is not a factor. It's 2 terms part of 4 terms. We can only simplify factors. 2x plus 7 in parentheses up here is not a factor. Okay? Yes?
So I get why you move the negative over, but how does that not affect the 2 times x minus 4?
Very good question. So let's do this. Let's say I have 2 times x times negative x plus 3. So this is 2 times x, negative x minus 3. 2 times x times negative 1, or negative 1 times x times 2 is negative 2x, x minus 3, no matter how you look at it. It's not a distributive law. I can't distribute. It's a multiplication. It's a product. Is that better?
Yeah.
Yes, Ryan, you wanted to say something? No. Okay, please choose another, because you have to do the rest. Please choose. We need to choose something with negative exponents. 15 is a good one. So 15 from the supplement. Okay. The cube root of x squared plus 3 times negative 1 times x to negative 2 plus 1/3 x squared plus 3 to negative 2/3 2x and x to negative 1. It's a mess. Thank you for picking that. You will be banned from picking again. No, I'm kidding. We needed to see it anyway. If you hadn't, I would have. I would have. Good. It's a mess. I don't like it. I'm going to rearrange it. Negative x to negative 2, x squared plus 3 to which power? I copy the negative, of course. The numbers go in front. I copied this quantity. I copied this quantity. I went the power.
1/3.
Awesome. Well done. When I multiply x by x to negative 1, what do I get? Copy the base, add the exponents. Copy the base, add the exponents. What do you get? x times x to negative 1 is x to 1 minus 1, which is x to 0, which is 1. X times x to negative 1, copy the base, add the exponents, x to 0 is 1. So this goes away as being 1. So 2/3 x squared plus 3 to negative 2/3. So we managed to clean it up pretty nicely. And now, of course, I'm going to ask you about common factors. But first, please identify how many terms we are looking at. Exactly. This is the first term, and this is the second term. They both have one factor in common. Let's pull it out. Very good, awesome. I have to ask myself which power. And the answer is always the smallest of the two. If you have power 1/3 and I have power negative 2/3, which one is the smallest? Of course, negative 2/3, of course. Remember the question from before? From power 3, I subtract power 2 to get the result as power 1. Stay with me, please. From power 1/3, I subtract power negative 2/3. From 1/3, I subtract negative 2/3, which is 1/3 plus 2/3, which is? Thank you very much. And I rushed by not, and I didn't copy this first. So I'm going to put it here. My apologies. I should have copied the negative x to negative 2 first, but I rushed because I was focusing on the factor. My apologies. Plus 2/3, and this is all out. There is nothing left. Okay, next. I hope you agree that this goes where? Yes, x squared plus 3. And I can go back writing it as a radical. But now let's talk about the numerator. I need to distribute this in here. 2/3 is 2/3. But when I distribute negative x to negative 2 to x squared, of course I get a negative number or quantity. But what is it? It's the same thing. X to the second power times x to negative 2 will be 1. And now I distribute this to 3, and I get negative 3 over x squared. Any questions so far? We do have to find the least common denominator in the numerator, which is? Of course, thank you very much. 1 was multiplied by 3x squared. What is the adjustment of the top, for the top? Of course, thank you very much. I have x squared, now I have 3x squared. What is the adjustment? Awesome. Very good. I know you worked on problems. I know you did the problems that we did last time because you answered perfectly. So I know that. It's very clear to me. Thank you for doing that. So -9, and I thank everyone who did that because you may have not want to speak up, but you did the work. Okay, so this is over 1. I copy the numerator, which is negative x squared minus 9 over 3x squared, and I flip the denominator. And I will pull out negative 1. I say that yes, this is a homework problem, this is okay, but it's a bit too much of calculations, and I think it's a tiny bit too much. Okay, so let's choose a few from here to work on for Tuesday, and then we'll maybe find the time to work on more. So I think 7 is good. I think 11 is good. And please work on 17. Just 3 for now for Monday. I'm sorry, for Tuesday, of course. 7, 11, and 17. So 7, 11, 17 from this supplement for Tuesday, please. I hope you're going to be curious and do more and check the answers just to make sure the answers are in the back. Okay, last section of this chapter, chapter 2, before we start functions. Last section, 2.7. And 2.7 is more equations and inequalities, but I'm going to focus on inequalities now. Okay. So let's go back for a second. You think you cannot keep those supplements straight? Look at me. Okay, it's right here under my nose. Okay, so let's see what we accomplished so far. Remember, we finished everything, 2.2, 2.3. Now 2.7, 2.6 web assign should be done between now and Tuesday. Please bring all your questions to class. So this is completely done. This is done, okay? So now we are working on this. So we are talking about linear and nonlinear inequalities. And we will be selecting from these problems in a minute. And this is done. Okay? We just went through it. So our next step will be functions after we finish 2.7. Okay? And this is the end of chapter 2. If we manage to finish 2.7 today, 2.7 should be worked on over the weekend as well. So from functions, I don't know how much we can accomplish next week, and then we'll stop, we'll review, and we'll take our test. Because I don't think I can finish. We have 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 5.7, 4.2, till test 1. It's impossible. So as I said, this is the first time I teach it from this book. So we have to put a stop so we can get the 4 tests in. Okay, inequalities. Last section of chapter 2. Let's look at some linear inequalities and absolute value inequalities. So linear. And here is one, number 13. X plus 3 over 8 minus x plus 5 over 5. So we are back to the book. And this is page 149. Greater than or equal to 3/10. And I remember, Caleb, last time he asked you what's the difference between a absolute value equation and inequality. So that's our next step. Okay, so this is linear. Why is it linear? It doesn't have x in the denominator. You see fractions, but it's not a rational inequality. It's a linear inequality. I recommend do what? What do you think? Remember the 2 keywords, either factor or simplify or both. What do you think I am going to do next? Multiply both sides by? 10 will not do. 40. The least common denominator is 40. I want to eliminate all fractions at the same time. So 40 over 1 times 40 over 1 times 40 over 1. I will definitely simplify, not multiply, by 8. by 5, and by 10. That's my first step. Can anyone dictate the new inequality without distributing? Do not distribute just yet. Just for everyone to see. Yes, awesome.
X plus 3
Awesome.
minus x 8 times x plus 5.
Awesome. Greater than or equal to 12. That's it. So the only complicated thing, if you want to say that, was getting rid of fractions. So please never be afraid of fractions, especially in an equation or inequality. You can always get rid of them quite easily. The next step we know it's going to be 5x plus 15 minus 8x minus 40 greater than or equal to 12. We combine like terms on this side. And this is minus 25. And we move negative 25. And we get 37. And x and 37 over, we divide both sides by negative 3. And we discussed this some time ago last week. What?
The sign was split sign.
Yes, because we divided by a negative number. We want to present the answer in interval notation. So let's graph it so we can see it. Negative 37 divided by 3 is a negative number. I really don't care where it is. I don't care for units. But I know that this is the interval. This is what I have to write. X in the interval, negative infinity, negative 37 divided by 3. Yes, please.
Can you explain one more time?
Yes.
Why the sign switch?
Yes. So let's take a look at the following example. Is 2 less than or equal to 10?
Yes.
Let's say, for whatever reason, I want to multiply both sides by negative 2. So on the real line, this is 2 and this is 10. Now, if I keep this, I'm really telling you that it is better to owe me $4 than to owe me, it's better that you owe me $40 than you owe me 4. But negative 4 is here and negative 40 is here. So obviously this is a bigger number than this. So every time we multiply or divide both sides of an inequality by a negative number, we must switch the inequality symbol. Is that clear? Yes? Flynn?
I'm just going to ask, it says x, I, n.
Yes, x is a value, a number in the interval.
Okay.
Yeah. X is a number in the interval. Yes, please, right?
That would be the final answer.
I'm sorry?
That will be the final answer.
Yes. I'm sorry.
Is that defined, I mean, that's kind of like a little squirrel. Is that?
That's the interval notation. This is the interval notation. You don't need to graph it. I wanted to graph.
Is that INT or is that?
No, it's IN. X is a value in the interval from negative infinity to negative 37 over 3. We normally use this symbol, but I didn't want to put it. I just wrote in. But this is the correct mathematical symbol. X is in the interval. Yes, Flynn?
On the sign, it just asks us for the parenthesis or bracket or whatever.
It's just labeling it. You don't have to put that.
Yeah, you don't have to put that in. But here's the problem. So if I tell you this, what do I mean? Aha. But if I put x in the interval, then you know I do not mean a point. What do I mean? An open interval between negative 2 and 3. So that's the reason why I put that in front. So it's specific for an interval. Very good. Other questions here? Other questions? Okay, so let's look at absolute value inequality. Do you think we need another one? We need another one? Yes, no?
Yes.
Yes? A linear? Okay. So let's look at 14, which is x minus 1 divided by 3 plus x plus 2 divided by 5 less than or equal to 3/5.
Where's the number 14? Is it in the book?
Oh, yes, well, still we are looking at the book, yeah. So this is still on page 149. Okay, let's work on it for 1 minute. We have an answer? Yes? What is the answer? Closed bracket? 1 to infinity? Perfect. Does anyone have the same answer? Yes? Okay, I'm sure it's good. So we are multiplying everything by 15. That's the least common denominator. 15 over 1, 15 over 1, 15 over 1. I'll simplify. So I get 5x minus 5. I'll simplify, and I get 3x plus 6. And I'll simplify, and I'll get 9. So this is 8x plus 1 less than or equal to 9. 8x less than or equal to 8. X less than or equal to 1. So the interval is from negative infinity to 1. Right? Because it says less than or equal to 1, we are not changing the inequality symbol. Is that okay, everyone? Perfect. Okay, so let's... Is that okay?
Yes.
Perfect. It's okay, we all make mistakes. Okay, finally, we reached inequalities, last topic of this chapter. Ladies and gentlemen, I know it's a lot. I know it's 2 hours, but please bear with me. Vanessa, please, just bear with me. So let's look at absolute value inequalities. Last topic. Absolute value inequalities. I'm going to explain how they work with very simple examples, and then you pick. Or I pick. Here it is. These are the only 2 possibilities. Either the absolute value is less than or equal to a number, or the absolute value is greater than or equal to a number. So let me explain what the first inequality is asking us to do. First of all, what does the absolute value of x mean? The distance between x and 0. It's a distance, right? The distance between x and 0 is the absolute value of x. The first inequality says this. Find x values whose distance from 0 is less than or equal to 2 units. distance from 0 is less than or equal to 2 units. The other one says, find x values whose distance from 0 is 2 units or more. 2 units or less, 2 units or more. So that's why the first inequality has the answer this. Basically, this. This inequality with absolute value changes into this, and it has this solution. This one will have this solution, which means it changes into two separate inequalities. X greater than or equal to 2 or less than or equal to -2. So the first one means in between -2 and 2. Numbers whose distance from 0 is 2 units or less. The second one is not looking for that. It's looking for 2 units and more. Means to the right of 2, to the left of -2. So this is the concept, totally different than absolute value equations. The equations have solutions like 1 or 2 or 3, but these are intervals. Okay, so please choose. This is from your book, page 149. So these are solve the inequalities involving absolute value. Write your final answer in interval notation. Let's start with 19. In 19, we have the absolute value of x minus 2 plus 4 greater than or equal to 10. This particular inequality is an absolute value inequality, but it's not completely cleaned up. We need to perform one step before we decide what to do. So what is that step? Yes, we subtract 4 or move forward to the other side. The absolute value of x minus 2 greater than or equal to 6. All I have to do now is think in terms of, am I looking for in between or am I looking for the outside? Which one? Is it in between?
Outside.
Outside. But this time, it's x minus 2. It's x minus 2 who has to be greater than or equal to 6, or x minus 2 who has to be less than or equal to -6. If I had just plain x, I would have written x greater than or equal to 6, x less than or equal to -6, but I have to write what I have in the absolute value. And now I solve this inequality, greater than or equal to 8 and less than or equal to -4. I know that this type of inequality requires the union symbol. It's the one that is more complicated if you want. Please give me this first interval on this side and the second interval on this side. And -4, very good. And you can put x in the interval. Union. Yes. That's it. This is one type of absolute value inequality. I know you've seen this before. And let's also look at the other type. The other type is easier. So this is 23 on the same page in the book, 149 book. X minus 3 divided by 4 less than 2. This one doesn't have to be cleaned up. It's already ready to be converted. So is it in between or is it the outside?
In between.
In between. But this is what has to be in between. In between -2 and 2, this quantity. So -2 less than x minus 3 over 4 less than 2. Now I have to clean it up. What do you think we should do first?
I have a question. Where did the -2 come from on the lower bound?
This one?
Yes.
Okay, let's go back. Whenever I'm asked to find the solutions of this inequality,
Oh, I understand.
Is that okay?
Yes.
So we will multiply all three sides by 4. And we will add what to all three sides? Very good, awesome. -5 less than x less than 11. And this is the solution. X in the interval .
8.
So -5 comma 11. In between -5 and 11.
It's only brackets when you use the infinity symbol?
No, brackets for the equal symbol. Whenever I have the equal symbol, very good question. Whenever I have the equal symbol, I use brackets. If I don't have the equal symbol, I have to use parentheses. There is no equal symbol here, there is no equal symbol here. There are parentheses. Any questions? Any questions? We have 3 more minutes. Please tell me what you would like me to do, other than take attendance. I'm going to take attendance right now.
Can you just go over what homework is going to be on Thursday?
Yes. Homework for Thursday.
Tuesday.
For Tuesday. We are done with 2.2, correct? And 2.3, correct? Okay, what was the next? The next. So we have 2.6 and 2.7. And those two from 2 supplements. Right? From the absolute value supplement. So this is Web assign, absolute value, and simplifying supplement. We selected from the simplifying supplement 3, and from the absolute value, please finish it up.
And then we do 2.7, 2.6, and then those 2 supplements.
Yes. Yeah, but from the big one, from the long one that we just looked at.